Cambridge IGCSE, February-March 2021, Paper 42. Question 1, Part A. Figure 1.1 shows a piece of glass of thickness 2 cm and area 0.15 meter square. The density of the glass is 2.6 into 10 to the power 3 kilogram per meter cube. Calculate the weight of the piece of glass. So in this question we are provided with the area of the cross-sectional area of a piece of a glass, and its thickness is also given. Thickness is 2 cm. So by multiplying the area and the thickness we will get the volume. So first we can calculate the volume of this piece of glass, that is volume is equal to area times thickness. So where area is 0.15 times thickness is 2 cm, that is 2 into centimeter we should convert to meter, so 10 to the power minus 2. So now we have volume, and density is also given in the question, that is density is 2.6 times 10 to the power 3 kilogram per meter cube. As we have density and volume, we can calculate the mass using the equation density is equal to mass over volume. From this, to calculate mass we can make mass as a subject, so we will get mass is density times volume. So we can calculate mass, that is the product of density and volume, where we have both the values. Density is 2.6 into 10 to the power 3 times volume is 0.15 times 2 into 10 to the power minus 2. So the answer is 7.8 kilogram. So we have mass, that is 7.8 kilogram. In order to calculate weight, we can use the equation W. Weight is equal to mg, the product of mass and acceleration due to gravity, that is 10. So we can substitute 7.8 times 10, we will get 78. So 78 Newton is the weight of this glass. Part B. The piece of glass shown in figure 1.1 is used as the vertical viewing window of an aquarium. The atmospheric pressure outside the aquarium is 1 into 10 to the power 5 Pascal. The average pressure on the inside of the aquarium window is 1.3 times 10 to the power 5 Pascal. Calculate the resultant force acting on the window due to these pressures and state the direction in which it acts. So in this question, this glass rod, the piece of glass given in the figure, has used as a vertical viewing window. So as it vertical, the piece of glass position will be like this, and inside this there will be water in the aquarium, and outside will be air particles, and the pressure outside the aquarium is given, that means the pressure exerting on this glass wall due to the air present at the outside of the aquarium is given. That pressure is 1.0 times 10 to the power 5 Pascal. Likewise, in the opposite side, the water inside the aquarium will also exert a pressure on the glass wall, and that is also given. This pressure due to the water molecules on the other side of the glass wall is 1.3 times 10 to the power 5. So now we can understand that both the pressures are exerting on opposite sides in opposite directions of this glass wall. So the resultant pressure on the glass wall will be the difference between these two pressures. So that will be the difference, and the value will be 0.3 times 10 to the power 5 is the resultant pressure acting, and we can see the pressure acting upward from the water is greater than the pressure acting on the glass due to the air. So the resultant pressure direction will be outwards as water pressure is greater. Now we need to calculate the force. So we can use the equation. Force is pressure times area, because we have the basic equation of pressure, that is force over area. We have just used the same equation here. In order to calculate force, we can rearrange. So we will get force is equal to pressure times area, and here we have to take the resultant pressure, which we have calculated 0.3 times 10 to the power 5 times area of this glass wall, which is also given 0.15. So the answer is 4500. So force is 4500 Newton, and the direction of force, as we know that the pressure inside the water is greater, the direction of force also will be in the same direction. So we can write the direction of force will be outwards. Part C. Figure 1.2 shows a vacuum pump connected to the top of a vertical tube with its lower end immersed in a tank of liquid. The pump reduces the pressure above the column to 0, and the pressure at the point X is 9.6 into 10 to the power 4 Pascal. So in this question we can see the vacuum pump is connected to a vertical tube. And it's mentioned in the question that the pump reduces the pressure above the column to 0. So the above the column or the above the water level means at this point the pressure is 0. And pressure at point X is also given, that is 9.6 into 10 to the power 4. So pressure at X, that is at this point the pressure is 9.6 times 10 to the power 4 Pascal. Now we need to calculate the density. So in order to calculate density, we can use the equation P is equal to pressure is equal to rho GH. Here change in pressure will be is equal to density times G times height difference or change in height. In order to calculate density, we can make density as a subject. So we will get change in pressure over G times change in height. So change in pressure is the pressure difference between the top and the bottom of the air column. So that is equal, the pressure at bottom of the air column is 9.6 times 10 to the power 4, and the pressure at the top is 0. Over G value is gravitational constant 10 times height difference. Height difference from the top and bottom is given, that is 12 meter. So 12, and the answer is 800. So we can write 800, and the unit of density is kilogram per meter cube. Going to question 2, part A. State what is meant by the moment of a force about a point. So since it is 1 mark question, we just need to write what is moment in one statement. So we can write it is the turning effect of a force about a point or a pivot. Part 2. Figure 2.1 shows a large crane on a construction site lifting a block of mass 14,000 kilogram. Calculate the moment about A due to the 14,000 kilogram block suspended from B. So we just need to calculate the moment due to this block at B about the point A. So we should calculate what is the turning effect or moment at B due to a block which is having a mass of 14,000 kilogram at a point A. So the point A and the position B are having a distance 20 meter. So we can calculate moment Using the equation, moment is equal to force times perpendicular distance from pivot. So what is the force of the block? As force is not given directly, but we have mass. So force is nothing but weight, and weight of the block will be mg. So we can substitute force is weight times perpendicular distance, where weight is mg times distance. We can substitute the values. So the mass is 14,000 times g is gravitational, field strength that is constant 10, and distance from the pivot. Here the distance from the pivot A to B is 20 meter. So times 20. And the answer is 2.8 into 10 to the power 6 Newton meter. So the moment is 2.8 times 10 to the power 6 Newton meter. Part B. Speed is a scalar quantity and velocity is a vector quantity. State the difference between a scalar quantity and a vector quantity. So we can write any scalar quantity has only magnitude, but a vector quantity has both magnitude and direction. You will get 1 mark for writing about scalar quantity and the next 1 mark for writing about vector quantity, which has both magnitude and direction. Part 2, write down one other scalar quantity and one other vector quantity. So in the previous section already one scalar and vector quantity example is given. We need to write another example. So we just need to write any other scalar quantity. We can write time, temperature, distance, any of these quantities which do not have direction. And the example of vector quantity, we can write force, weight, acceleration, any of the example of a quantity which has both direction and magnitude. Part C. Figure 2.2 shows two forces acting on an object. Draw a scale diagram to determine the resultant force acting on the object. State the scale you use. So in this figure, two forces are acting on an object. As you can see, 20 Newton force which is acting vertically downwards and a 30 Newton force which has both vertical and horizontal components. This 30 Newton force is acting 60 degree from the vertical line, as you can see. Now we need to draw a scale diagram to determine the resultant force acting, or due to these two forces what will be the direction of the object it finally moving. So here we have two vectors. One is 20 Newton which is acting vertically downward, and another one is 30 Newton. And the 30 Newton is acting at a 60 degree angle away from a vertical axis. And we need to find out what will be the resultant of these two vector forces. So in order to draw a scale diagram, we just need to combine these two vectors. But we have to be careful that when we add this vector, that 30 Newton vector to 20 Newton vector, you should keep it in a way where the head of the 20 Newton and the tail of the 30 Newton force are connecting together. In such a way you should always draw vector diagram. So here basically we have two vectors, 20 Newton and 30 Newton, and in order to find the resultant vector we should combine these two vectors. But when you draw, you have to make sure when you draw the 20 Newton vector, the 30 Newton you should connect in such a way that the head of 20 Newton should connect to the tail of 30 Newton force, and you should take a protractor and measure it's at 60 degree away from vertical line. As I am drawing on the screen I cannot use ruler, but when you draw you should take a ruler and a protractor to draw it neatly. So in order to draw we need to take a scale, and we can take for 10 Newton force 1 centimeter. So in order to draw the 20 Newton you should draw a 2 centimeter line exactly vertically downward. Take a ruler and draw a 2 centimeter line vertically downwards. Then you can draw a vertical reference line. Then you can keep a protractor here, or you can draw the reference line vertically downward and keep the protractor here. That will be easy. And from here you can measure 0, 1, 2, 3, like where you are getting a 60 degree. So it will be somewhere here. So that is 60 degree. And from there you have to draw a 30 Newton. 30 Newton means it will be 3 centimeter line at 60 degree away. So now we have 20 Newton force, which is exactly downward. Its head we have connected to the other vector which we need to add with this, that is 30 Newton. And be careful when you measure the angle. Make sure you have taken a protractor and draw it. So you will get a figure like this. In order to find the resultant, you just need to connect the other side of this triangle. So this will be the resultant vector. You should connect it properly, and the arrow should be the opposite of these two vectors which we have already drawn. As you can see, the 20 Newton and 30 Newton are directing in a clockwise direction like this. So the resultant should be in anti-clockwise. 20 Newton and 30 Newton are directing in a anti-clockwise direction. So the resultant vector, that is the third side, should be directing in opposite direction, in a clockwise direction. So we should put an arrow in this direction. You don't need to draw these direction arrows. So the third side is the resultant force, and in order to find the magnitude of this resultant force, you can take a ruler and measure this length. So if you draw it properly, you will get this length is 4.4 centimeter. So when we convert into Newton using this scale, that for 1 centimeter 10 Newton, here we will get 4.4 centimeter times 10, that is 44 Newton. So this is the resultant force. So So we can write down this resultant is anti-clockwise from 20 Newton force. Question number 3. A power station burns waste materials from farm crops to generate electricity. State and explain whether this process is renewable. So here the electricity is generated by burning the waste materials from the farm crops. As the crops can be regrown or the waste materials don't run out, it is a renewable energy resource. So first of all, the statement we can write down, it is renewable, but we need to give the explanation. So we can write crops can be regrown. Part B, the power station uses some of its waste thermal energy to heat water for houses in a nearby town. State one problem of using waste energy in this way if the power station is far from the town. So the heat energy or the thermal waste energy produced at the power stations will be used to heat the water for the houses next to the power station. So this wastage of energy again can be utilized for a useful purpose. But this process is using only for the houses in nearby towns. You should mention what is the problem of using the same waste energy in the same way if the power station is far from the town, or if the houses are not too close to this power station. Why can't we use this waste energy to heat the water in such houses? So if the houses are too far away, when the thermal energy is transferring from this power station to the houses, it has to travel a long distance, but by that time of traveling the long distance, the water will cool down. So we can write as one problem, water will cool down. Suggest a way to reducing this problem. So by inflating the pipes, we can keep the water cold for long time. We can write inflate the pipes. Part C, state the environmental consequences of burning coal to generate electricity. So we just need to write down two disadvantages of coal as an energy resource. So the first point is air pollution, and the second point is non-renewable. Question number 4, part A. In terms of the momentum of molecules, explain how a gas exerts pressure on the walls of its container. It is a very important, frequently asked question in so many past papers. So there are some key words you should include while writing this answer in order to score 4 marks. So I will just explain point by point. So first we can consider a container which consists of air particles, and we know that these air particles, they are free to move and they move randomly in all directions. So when they move, they will collide with the walls of the container. So that is the first point we can write. Molecules strikes walls. Now let's look at the molecules. What will happen when they strike at the wall? So we can concentrate at one molecule. When it strike at the wall, it changes its direction. Even though its speed is same, but its direction has changed. As you can see, when the direction changes, the momentum of the particle will also change, as momentum is a vector quantity, direction matters. So as you can see in this molecule, when it strikes the wall, it return back and its direction changes, so its momentum will also change. So that is the second point we need to write, that the momentum of the molecule changes. Now as there is a change in momentum, we can conclude that there must be a force exerting on the wall by this molecules, as we know that force is rate of change of momentum, and now we realize that there is a change of momentum occur when molecule strikes at the wall, and it will take time for the collision. So because of this, there will be a force also exerting on the walls by the molecules when it strikes. So to indicate this point, we can write force equation, that is force is rate of change of momentum, or you can write as force is equal to rate of change of momentum. Molecules exerts a force on the wall, and we know that if there is a force acting over an area of the wall, there will be a pressure exerting on the wall. So we can write down there will be pressure also due to this force, as pressure is force over area. So these are the important points you should write, and all these words are very important keywords, that molecules strike the walls and momentum of the molecules changes is important. So these highlighted points are the keywords in order to score 4 marks. Part B. A fixed mass of gas of volume V1 is at pressure P1. It is compressed to a volume V2. Complete the equation for the final pressure P2 of the gas when the gas is compressed at constant pressure. So here we can use the Boyle's law, that is the product of pressure and volume at the initial state will be equal to the product of the pressure and volume at the second stage. So from this we need to find out what is P2. So first we can write according to Boyle's law, P1 V1 is equal to P2 V2. Now going to question number 5. 2 times mega. When we convert into numbers, it is 10 to the power 6. So we can write 10 to the power 6 hertz. And the answer is 7.5 times 10 to the power minus 4. So we can write 7.5 times 10 to the power minus 4 meters. The unit of wavelength is meters. Part C. Figure 5.2 shows crest of a wave from a point source S approaching a straight barrier. On figure 5.2, indicate and label one wavelength. So on figure 5.2, we have to label one wavelength. So it's mentioned that the crests are shown in the figure, and a wavelength is the distance between a crest to crest, or the distance between two consecutive crests is wavelength. So here, in order to indicate a wavelength, we just need to connect the distance between two consecutive crests, and which is represented by lambda. Part 2. On figure 5.2, draw 3 crests of the wave reflected from the barrier. So when it reflects back, the wavelength lambda, that is the distance between the crest, will remain same, but the direction will be in opposite way. So the wave will be moving backward. So you can draw rough diagram like this, but make sure this distance between these crests are again same as lambda. Going to question number 6. Part A. Figure 6.1 is a full scale diagram showing a converging lens. The two principal focuses f1 and f2 and an object PO. So there is a converging lens and principal axis drawn, two principal focuses and the object. Everything is given in the picture. On figure 6.1, draw two rays from point O of the object to determine the position of the image. Label the image IJ. Measure the length of the image. So we need to draw a ray diagram. So on figure 6.1, we need to draw two rays from O of the object to determine the position of the image. So we need to draw two rays emerging from O, and what will happen to these rays when it is passing through the lens. So when we draw ray diagram, we should include two important rays. The first ray is a ray which is parallel to the principal axis, and the second ray we should draw the ray passing through the optical center. So first we can draw a ray which is parallel to the principal axis. What will happen when it is passing through the lens? You should take a ruler and a pencil in order to draw this. So from point O we have to draw the ray as it's mentioned in the question, from point O. So we can start the first one, the ray which is parallel to the principal axis, starting from O. So it should be a straight ray, a parallel ray. When it reaches at the center of the lens, it will pass through the principal focus at the other side of the lens. It should be straight line like this. So the first ray we have drawn, which is a parallel line to the principal focus, but when it reaches at the lens, it will pass through the principal focus, staying at the other side. Now we can draw the second ray that is passing through the optical center. So another ray emerging from position O, and it should passes from the center of the optics, and this line will not deviate but it will pass straight. Without any deflection. So the ray which is passing through the optical center will always continue to move in straight line without any deviation or deflection as shown in the figure. Now we can draw the arrows to indicate the direction. As we know, these rays will be moving in this direction, and an image will be formed when these rays, or at the point where these rays are intersecting. But here, by looking at this picture, it's clear that these lines will not intersect because they are moving apart. So the image is not going to form, or these rays are not going to intersect at this side of the lens. So we are not going to get a real image, but we will get a virtual image at the other side of the lens. In order to get that, we should extend these rays and check where these rays are meeting or intersecting. So for that, we should extend using a ruler these two lines. So we will get a point where these lines intersects, and at this point the image will be formed. So as the real rays are not intersecting at any point, we just need to extend the rays to the other side of the lens as shown in the figure, and the point where the rays intersect, we will get a image. So the image will also have a position same way up as the object, as we can see, but the image will be a magnified image. Comparing to the size of the object, the image size is greater. And as we have seen, the image is formed not from the intersection of real rays which is passing through the lens. The image is not real but virtual. Now we need to measure the length of the image length. So you should take a ruler and measure what is or how much is this length. And if we draw it properly, we will get this length as 3.1 centimeter. So we can write 3.1 centimeter. But any value in the range from 2.4 centimeter to 3.6 centimeter, you will get mark. Part B, ring 3 descriptions of the image. So the first one given is diminished. No, we have seen the size of the image is greater than the size of the object. So it's a magnified image, not diminished image. So the magnified is correct. And the third one is real, but we know that the image is not formed from the real rays. We had to extend to the other side. So again, it's not real but it's virtual, and it's given same size. We have seen that the image size is greater than the object size, so the same size answer is also wrong. Next point, same way up as the object, that is correct. Both object and the image are having same direction, so this option is correct, same way up as the object. So we have put 3 rings in order to describe this image formed. Part C, figure 6.2 shows 3 rays of green light passing through glass blocks. 3 rays of red light approaches the glass block on the same path as rays of green light. On figure 6.2, draw the paths of these rays of red light to the right of the glass blocks. So as you can see, there are 3 glass blocks and light rays are passing through these glass blocks. Initially, 3 rays of green light passing through the glass blocks. So we can see the green rays, they are moving straight, but when these green rays are passing through these glass blocks at an angle, they are undergoing the process called refraction. Because of that, they are bending. But the center green ray, it is passing at 90 degree to the normal. So the angle of incidence is 0, so that the angle of refraction will also be same. So it will move straight without any bending. Now 3 rays of red light approach the glass blocks on the same path as the rays of green light. Now 3 green lights also passing on the same path where green light also passed. So what will happen to the red light rays? Will it follow the same path of the green light followed like this, or there will be any difference? So that is the question here. So here we know that the amount of refraction of different light rays or different colors of lights depending on its frequency. So when we consider the colors from violet, indigo, blue, green, yellow, orange, red, violet color has highest frequency and red color has lowest frequency. So the light colors which are having more frequency will refract more. So here violet, which has more frequency, which will refract more or bend more, whereas the red color, which is having less frequency, will refract less or it will bend less comparing to violet color. This is a very, very important concept you should always remember in order to answer these kind of questions. So let's look at this question. Here we have green light and red light. Let's check which color, whether green or red, is having highest frequency. So when we write the colors violet, indigo, blue, green, yellow, orange, red in the order of VIBGYOR, the frequency is reducing from left to right. So we can understand that green has more frequency comparing to red, or red has less frequency comparing to green. So less frequency means less refraction. So red color has less frequency, so it will refract less or it will bend less comparing to green ray. So when the red color passing with the same path of the green, but when it is passing the prism, it will refract with a less amount. So this will be the path of red light. But the red light which is passing straight or 90 degree will pass straight without any deviation. Again, the last ray, when it reaches the prism, it will refract, but the amount of refraction will be again less than the green light, as we can see. So these are the path of red light. Question 7. Figure 7.1 shows a horizontal conducting wire XY. Between two poles, wire XY forms a circuit with an ammeter A. Part A, explain why the reading on the ammeter is 0 when the wire XY is not moving. So in the given arrangement, we have a magnetic field due to the presence of two opposite magnetic poles, north and south poles. So because of these permanent magnets, there will be a magnetic field in between the poles of this permanent magnet, and the field lines will be emerging from north pole to south pole. The direction of the magnetic field will be always towards south pole. So there will be field lines between these two poles of the magnets. And a wire XY, which is a conducting wire, that means a current can flow through the wire, which has kept in between these magnetic poles, and this conducting wire is connected to a ammeter. So ammeter will show a reading whenever there is a current flow in this conducting wire. In part A, we need to explain why the reading on the ammeter is 0 when the wire XY is not moving. So, in order to answer this question, you should know about electromagnetic induction. So, electromagnetic induction is nothing but a production of electricity or production of current or generation of current in this wire. Without connecting to any power supply or any cell, there will be a current automatically generate in this wire. That type of current is called induced current. Induced current or induced EMF. But how this current will be formed? That is very important. So there will be a current formed in this wire XY, or there will be an induced current in XY only when this wire, which should link with the magnetic field lines, and the number of field lines touches this wire should keep changing. So I will just draw and explain more clearly. As we have already seen, because of the presence of these two permanent magnets, there is a magnetic field in between the poles and field lines are going from North Pole to South Pole. So these field lines are passing through this wire XY because we have kept this wire XY exactly in between these poles. Now, when you move this wire XY upside down, what will happen? The moment you start moving this XY wire, it will act as a knife which is cutting these field lines. Right? When you move the XY wire downwards, it is cutting the field lines. Likewise, when we move the wire upward also, the wire will be cutting these field lines. So the cutting of field lines by this conducting wire XY, or in other words we can say the number of field lines linked with this wire XY, linked or in contact with the wire XY, is keep changing. So in this case there will be a induced current which will be flowing through the wire XY. So this is very important concept about electromagnetic induction or induced current. So in order to generate a current or induced current in a wire, this condition has to be satisfied. The number of lines linked or connected with the wire should keep changing, number of field lines. Now let's look at the question. Explain why the reading on the ammeter is 0. Reading on the ammeter is 0 means there is no current or no induced EMF generated in the wire XY. That's why no reading. Here the reason is we have seen the condition to generate the induced current is that we should keep changing, moving this wire upside down. Then only the field lines will get cut and that will cause a generation of induced EMF. But as long as we are not changing the position of the wire, or the wire is staying at the same position, the field lines are touching, or the magnetic field lines are touching or linked, but it's not changing or it's not cutting. As long as there is no cutting, there won't be any current. So in order to have an induced EMF in the wire, we should keep moving the wire XY in between these field lines. So here we can write no cutting of magnetic field lines, or you can write no cutting of magnetic flux. Another word of field lines is magnetic flux. Part B, the wire XY is moved and there is a deflection on the ammeter that indicates there is a current in the wire from X to Y. On figure 7.1, tick one box to indicate the direction of the movement of the wire XY and explain your answer. So now in part B, the wire is moving, and we have already seen that when the wire moves, the cutting of the field lines will happen, and that will cause a induced current. So when the wire moves, there is an induced current which will cause a reading in the ammeter. Now in part B, it's mentioned that when the wire is moving, there is a current in the wire from X to Y. This is very, very important. That is, there is a current flowing from X to Y. So the direction of current is from X to Y, or a current, induced current is flowing from X to Y, or that means into the page. And we already know that the magnetic field lines are directing from left to right, as it's from North Pole to South Pole. We can see magnetic field lines are directing from left to right in this direction. So now we have two directions which is already given in the question. One is the flow of induced current, that is into the page, and the second one is the magnetic field direction, that is from left to right. We can understand that from looking at the poles of this permanent magnet. Now, as per the question, we should understand the direction of the movement of the wire XY, or in which direction we should move the wire in order to have a current flow from X to Y. So this wire XY, whether we should move upward or downward, or into the page or out of the page, in which direction we should move this wire XY in order to have a current flow in this direction, that is into the page. So here, in order to get that direction, we have to use Fleming's right hand rule. For induced EMF concepts, we should use always Fleming's right hand rule. So according to Fleming's right hand rule, we can keep our three fingers perpendicular to each other, where the thumb will always represent the movement of the wire, or in which direction we should apply force in order to move the conducting wire. So the thumb represents motion, direction of the motion, or the direction of the force on the wire. Second finger, that is the index finger, represent the direction of the magnetic field. So the second or index finger we should point in the same direction of magnetic field. And the third finger, that is the middle finger, which should always point in the direction of the current flow. So these are the different fingers you should point in order to indicate the directions of the force, magnetic field and current flow, and this is known as Fleming's right hand rule. And right hand rule you can use for electromagnetic induction or generator effect. Now in this case, we have the direction of the flow of current, that is into the page, which we already discussed and mentioned in the question. So the current flow, third finger or the middle finger, you should point into the page. And the other direction we have is the magnetic field, that is from left to right. So here the second finger represents the magnetic field, and that you should point. So the second finger you should point from left to right, as here in this case the magnetic field direction is from left to right. So you have to hold your right hand where the third finger should point into. So the third finger should point into, and the second finger should point towards the right side, as it represents magnetic field. So this should be the third finger and this should be the second finger. Then we can check in which direction the thumb is pointing. Make sure to keep all the fingers perpendicular to each other. So we can understand the thumb is pointing upwards. Sorry, you have to try with your own fingers, and my drawing is not good. You cannot understand from this drawing, but try to do it yourself. When you do it properly, you can understand your thumb is pointing upwards or to the top of the page. Now let's look at which option is correct. Into the page is wrong, out of the page is wrong, to the left is wrong, to the right is wrong, to the bottom of the page is wrong, and yes, it is to the top of the page. As we have already seen, the thumb is pointing upwards. So the correct answer is the last box. All other options are wrong. Explanation. We need to give explanation for this. So first we can write all these terms, that is current, motion and magnetic field. All these three should be mutually perpendicular to each other. And next point we can write current directing into the page and magnetic field is from left to right. So definitely the third perpendicular will be upward. You can use Fleming's right hand rule. Part C. State what is observed on the ammeter when the wire XY is moved in opposite direction of part B. So in part B, when the wire moved, there was a current flow and the ammeter was showing a deflection. But now the current is moving in the opposite direction. So when the movement is changed to an opposite direction, there will still a current flow, but the direction of current flow will be in opposite direction. So the ammeter will deflect in opposite direction. So we can write down opposite deflection on ammeter. And part 2, in the same direction as part B, that means the wire is moving as the same direction as part B, but at a greater speed. So we should understand that when the cutting speed increases, the rate of cutting increases, so more current will be flowing. So we can write whenever there is movement with higher speed, the current will be more. So we can write greater current, or in terms of deflection we can write down greater deflection. Part 8, question number 8 is from the topic electricity. Define electromotive force. So this is a very important definition you can find in many past papers. So you should study this definition using the same keywords mentioned in the answer or in the mass key. So the definition is, it is the energy needed to drive 1 coulomb charge around a complete circuit. And these highlighted words are very important keywords. You should include these words in order to score marks. So basically EMF is the potential difference or voltage of a cell, and we know that this voltage or energy of a cell is the energy which provides to the whole circuits to work, whether there is any components in between. The energy or the voltage from the cell provides enough energy to work the whole circuit. So this voltage across the cell is known as EMF. But as a definition, you should include these all keywords. Part B, figure 8.1 shows a source E of EMF 60 volt in a circuit. So we have seen EMF is nothing but the voltage across a power supply or a cell. So here this is the power supply to this whole circuit, and this EMF is given, that is 60 volt. The heater H has a resistance 22.5 ohm and the potential difference across it is 45 volt. Calculate the power of the heater. So we have a heater here. Its resistance value is given, and the resistance of this heater is 22.5 ohm, and one more value is given for the heater, that is the voltage across this heater is 45 volt. So the voltage across this heater is 45 volt. So you should understand one important thing, that the total EMF is 60 volt, or the total energy supplied to the whole circuit is 60 volt. Out of 60 volt, the 45 volt is consumed by the heater, as the potential difference between the heater is 45 volt. So from this you can understand, out of 60, 45 is consumed by the heater. So the remaining voltage, that is 60 volt minus 45 volt. So we will get 15 volt. So the voltage consumption across this parallel circuit will be 15 volt. This is a idea we should have when we solve these kind of questions. So here it's not mentioned that the voltage combination or the voltage difference across the parallel combination is 15 volt, but we should understand that by looking at the voltage across the heater. If the voltage across the heater is 45, then out of 60 the remaining voltage will be the voltage across the parallel combination. So these are the informations we have now. Now let's look at the question. First part, we need to calculate the power of the heater. So we have the resistance of the heater, we have the voltage across the heater. So if we have V and R, we can calculate power using the equation power is equal to V square over R. Actually we can calculate power using many equations. Basically we have three important equations for power, that is power is the product of voltage and current, power is equal to I square R, power is equal to V square over R. You can use any of the equation. As we don't have current, the easiest way to use power is V square over R, where V is 45 square over R is 22.5. So the answer is 90. The unit of power is watt, so 90 watt. Next part 2, the PD across resistor X. So the potential difference across resistor X, which we have already calculated, as the total voltage of the circuit is 60. Out of that 45 is consumed by the heater, then the remaining will be the potential difference across the parallel combination, and we subtracted and we calculated it is 15 volt. Since it is 2 mark question, we have to write enough steps. So we can write PD across X is the total voltage generated, that is the EMF, minus the voltage consumed by the other component, that is heater, which is 45 volt. So we will get 15 volt. So that will be the potential difference across the parallel combination or across X resistor. Part 3, the current in the 10 ohm resistor. So now we need to calculate the amount of current I flowing through the 10 ohm resistor. What is the value of I which is flowing through this part? This is what we have to calculate. So now let's concentrate at this resistor. Here we have a resistor and its resistance value we have 10 ohm, and the voltage across this 10 ohm resistor is 15 volt. The voltage across parallel combination will be always same. So we have voltage, that is 15 volt. Now we have voltage and resistance, so we can calculate current using the equation V is equal to IR. From this, in order to calculate current I, make I as the subject. So we will get I is equal to V over R, where the voltage we have just calculated in the previous part. 15 over resistor is given, resistor of 10 ohm resistor itself 10, and the answer is 1.5 ampere. So we can write the answer, the current is 1.5 ampere. Question 9. Write down the truth table for an OR gate. So let's draw the truth table. So for a OR gate, there will be 2 input and 1 output, and the possible inputs are, we should start from 0, 0, 0, 1, 1 0 and 1 1, and the outputs of OR gate is 0 1 1 1. You can draw a neat table using ruler and a pencil. Part B, draw the symbol for a NOR gate. So this is a OR gate. NOR means we should put one NOT and there should be two inputs and one output. So we can write input, two input we will have and one output also we will have. Part C, figure 9.1 shows a digital circuit design to produce the values shown in table 9.1 for the output S from the two inputs P and Q. The table 9.1 is the truth table for the circuit shown in figure R. Complete the column for point R in the table. So first of all we should complete this R by looking at what will be the output we are getting at R when we give the different values at Q. Values given to Q we can understand from the table which is given. So let's see, when Q is 0, the output which we are going to get at R will be the NOT of 0, that will be 1. So we can write down, see, just a NOT gate will give you an opposite value. So when Q is 0 we will get 1 as output. When Q is 1 we will get 0 at R. When Q is 0 we will get 1 at R. When Q is 1 we will get 0 at R, as it's a NOT gate. Part 2, state which type of gate is used for gate X. Explain your answer. So at X there is a gate fixed, but which gate is that we have no idea. But looking at the table and by looking at the values of the inputs, that is P value and R values, that are the inputs of the gate X. And when we give these two values, what is the output we are gaining at R? So we can see, as P is one input and R is the other input, these input values are 0 1 0 0 1 1 1 0. This is first input, this is a second input combination, third input combination and fourth input combination. And these input values, the output at S is 0 0 1 0. Now we can see which of the gate will give a truth table like this. When two inputs are having this value, the output should be as given. So from this we can understand this is a truth table of AND gate. For an AND gate, the truth table is, the different input options are 0 0 0 1 1 0 1 1, and only for the combination when both the inputs are 1 only we will get 1 as the output for an AND gate. All other will be 0, and here also we can see that we are getting 0 for all the combination except 1 1. So definitely it must be an AND gate. So we can write as the statement, it is an AND gate. And we need to give the explanation here. So as we discussed, we can write down, when inputs are 1 and 1, the output is 1. For all other combination, or whenever there is a 0 in the input, the output is 0. So any 0 input gives 0 output. Last question, question number 10, part A. State the proton number, nucleon number and the value of the charge on an alpha particle. So here we should know that an alpha particle is similar to a helium nucleus. So when we look at the helium, symbol is 2 4. From this we can understand the nucleus of helium consists of 4 nucleons. or totally 4 particles. Out of these 4 particles, 2 are protons and the remaining are neutrons. So it consists of 2 protons and the remaining, that is 4 minus 2. So we will get 2 neutrons also. So the first part we need to write proton number. Proton number is written at the bottom side of this atom, that is 2. So we can write proton. Nucleon number we get from the top, that is the sum of protons and neutrons, that is 4. So nucleon number is 4. And the charge, as we know that the alpha particle is similar to helium nucleus and nucleus always having a positive charge. But how much is the charge? 1 proton in the nucleus gives 1 plus charge, but here it consists of 2 protons. The total charge will be plus 2. Part B. A nucleus of strontium-90 consists of 38 protons and 52 neutrons. Strontium-90 is a radioactive and decays by beta emission to an isotope of yttrium. The symbol for strontium is Sr and the symbol for yttrium is Y. Write down the nuclide equation for this decay. So initially we have strontium, which consists of 38 proton and 52 neutrons. So 38 plus 52, that is 90 nucleons. So we can write that first. We have strontium with 38 proton and 90 nucleon number, and which decays 1 beta emission. So beta is similar like an electron, which is having -1 and 0. You should memorize the symbol of beta, then it will be very easy. And the other product is yttrium, which is represented by Y. And in order to check the proton number, we can see that the total proton number at the LHS and RHS should be equal. So at LHS it's 38, then at RHS also it must be 38. In order to get a 38 total value, it should be 39. So 39 plus -1, we will get 38. Likewise, to balance the nucleon number, at LHS it's 90, at RHS also it is supposed to be 90, but the beta emission does not contribute anything to the nucleon number. So for yttrium, the nucleon number should remain 90. Now at RHS is also 90 and LHS is also 90. So the nucleon number and the proton number is balanced. Part C. The half-life of radon is 220. Radon 220 is 56 seconds. A sample of radon 220 is in a container. After 112 seconds, the mass of radon is 9.2 milligram. Calculate the mass of the original sample. So initially we have a sample of radon and its mass we have no idea. Let it be X. But after 56 seconds, that is its half-life, its mass will become half of this value. So now after 56 seconds, after one half-life, its mass will become the half of its initial value. After 56 more seconds, that is the second half-life, its value or its mass will again become half of that value, or x over 2 times 2, that is x over 4, and this mass is given, that is 9.2 milligrams. So what is the value of x? That is the question. So first we can check the number of half-lives. That is the half-life over total time. So we will get half-life is, the total time over half-life. where the total life or total time undergone is 112 seconds, over the half-life is 56. So we will get 2 half-lives. So after 2 half-life, its mass is 9.2 milligram. So its original mass or its initial mass will be 4 over 9.2, that is 37 milligram. So that is the correct answer, 37 milligram. Thank you for watching this video. If you find this video useful, please subscribe my channel and like this video. Thank you.